The blades are 120 meters long, some of them, the biggest ones, in the North Sea on a tower that's like 150, 200 meters tall.
70% of all large construction projects are either over budget or delayed.
One of the main bits of feedback we got was actually that we hadn't asked for enough money.
It's not like a lack of want or ideas within those firms. It's just their kind of money talks, basically. And
or deadlines talk. Right? Yeah. They'll say they completely know, but we don't have time to do it. They don't have time to try the more efficient method.
Construction is complex. There is a lot of different parties involved, and obviously the risk is also high if something goes wrong, and therefore that's probably why maybe some processes are stuck to because they work and they've been successful to get there.
I think the other thing that's really important is making sure we make really good buildings. So if you make a crappy building that gets knocked down in 20 years, that's pretty much the worst thing you can do.
Welcome. So this is our first ever episode of the Constructed Insight podcast. The podcast where we're aiming to talk about construction, technology, innovation or lack thereof. Today's episode, we're going to get into a little bit around the construction process and some of the inefficiencies related to it. I actually heard a stat the other day that 70% of all large construction projects are either over budget or delayed, and I think we all have some experience with that from a personal level as well. But before we get into all of that, we've obviously got our first guests on the podcast today. So joining me today are Jack and Harri from Mule Studio. They've got a really interesting background, and to kick things off, we'll hand over to you guys to explain what Mule Studio is and maybe a bit about your backgrounds and how you got to founding Mule Studio.
Great. Well, thanks for having us here. Thanks. Honoured to be the first guests. Should we start with Mule Studio or ourselves?
Let's start with Mule Studio. Why not?
So Mule Studio is a interdisciplinary design studio led by Jack and myself. We see ourselves as sort of experimental agents within the industries that we work in. We work in construction, industrial design, teaching, software recently. We quite enjoy what we do. I think that's the key thing. We sort of look at what we enjoy and what we're good at, and we experiment in that field.
But yeah, we kind of actively try to do as many different things with the skill sets we have as possible, rather than kind of honing in on one specific kind of speciality. We try to say like, oh, we can do this and this and this. Let's try and do this kind of thing.
Yeah,
or
and
like,
I think that
we can do this and this. If we learned how to do this, then we could do this. So we're always trying to spread our net wider and wider and wider.
And I think that's evident. So if you on your guys' website, you go from designing small watches to working on large construction projects. So maybe it'd be good to just learn a bit more about the different fields and the similarities and I guess some of the differences in how they work.
Yeah, so maybe if we say our background, and then that sort of leads into that. So I am trained as a structural engineer, then saw quite early on in my career, that people were using computers more and more in a more creative way. And then I've sort of now become what we call a computational designer. And my definition of that, there's many people's definitions, but my definition is someone who goes from just using software to someone who has some part in the creation of software. And that's a really powerful difference. So if you get to a problem and you can't solve it, or your software can't solve it, you can create software to solve it. And that's something I say to engineers all the time. You never want to say to a client, I can't do this, or our software can't do this. That's just a not acceptable position to get into. So if the answer is a bit of software, then we should create it ourselves. And then I suppose after being a computational designer, I've become a studio founder or a business founder, I suppose, with Jack.
So my background was originally in architecture. So I trained as an architect and then moved more into kind of experimental R&D type architecture, kind of investigating new materials, new ways of building things. Then from that kind of moved more into product design and industrial design and some computational design as well. Again, kind of keeping a bit of a focus on this kind of the innovative side of it, always looking to try and find new ways or better ways of doing things, using different materials in different ways. So we still kind of dabble with a bit of small scale, kind of slightly more experimental architecture. But most of my time now really is in the kind of the product and industrial design world, really.
And so it sounds like both of you, from a architect's and a engineer's perspective, in your previous roles had a want to do things better, or there was a chance to improve what you were doing or how the industry was working in a way. So it'd be good to kind of understand a bit more about that and how that transitions to some of the stuff that you do at Mule right now.
Yeah, definitely. I think when we started the company, I think we often kind of said that we wanted to just be able to do whatever we wanted, whenever we wanted, basically. Like if we found something interesting, we wanted to be able to go, that's really interesting, let's work on that for a few months and see where it goes, rather than being at an architect's practice or something where the response would be, oh no, that's not what we do. So we definitely wanted that openness to explore interesting ideas when they came up and not be kind of restrained by a particular typology of design practice.
I think definitely the same in engineering. Engineers have a very focused idea or kind of narrow idea. This is what we do. And again, we're always encouraging people to sort of look sideways and see what other things you can do with the skills that you already have. And I remember my first job, I remember being shown how we were going to design this building and saying, is this really it? Is this how we're going to do it? And the people around me quite rightly said, yeah, have you got any better ideas? And at the time I didn't have any better ideas. So that's when I went away and studied. And maybe it's interesting how we met as well.
We actually met at a sort of an architecture school, what we call a crit, which is basically when students kind of present their work and you have people kind of coming in to give feedback on it. So it was just after I had left architecture school, I'd kind of gone back to help crit on my old sort of unit there. And I think Harri had been invited in as a sort of a structural sort of consult to give a bit more kind of real world sensibility. And I think, we kind of just found that we really agreed with the feedback each other were giving. And it was sort of, I think from there, I think it just kind of started from there. We just kind of kept
and
the
a
ideas
mutual
rolling.
burrito obsession.
Yeah.
Who doesn't have a burrito? Yeah,
we kept meeting for burritos.
Probably the first year and a half of Mule meetings were conducted in burrito places. And then I guess tellingly, like the first project we actually worked on together was an Innovate UK sort of funding application to develop a system for building small scale kind of structures using an inflatable membrane that you then injected with an expanding foam that was set into like a rigid form. So you kind of get like the kind of the benefits of inflatable structures, but also of like rigid, solid building structures.
Mm-hmm.
So really quite experiment. I mean, we didn't actually get the funding, which is
in hindsight, it was like a ridiculously naive application.
But again, I love that we were experimenting in that way. And also, one of the main bits of feedback we got was actually that we hadn't asked for enough money. We had really tried to keep all the costs down. We'd arranged deals with people.
Lent on everyone. It's like, oh, come on, do this for free, and then if it goes anywhere, you'll get the business afterwards, kind of thing.
And they didn't believe that we could have done the thing that we said we could do for the money. I mean, maybe we couldn't have. We'll never know. But that was one interesting takeaway from that. I think it's
super hard to get funding from them.
Yeah, we got one later.
Since then we have got funding from them.
Okay.
But we definitely learned.
We've learned a few lessons. Well, I think we could jump into a couple of lessons that we've.
The main lesson we learned, so we were really lucky. The second round we were doing it for was we were developing a tool for repairing wind turbine blades, which was it's still an ongoing project. Really, really interesting that the leading edge of wind turbine blades gets eroded very quickly, and despite it being a multi-billion-dollar industry, was not a very effective method for repairing these blades on site. Partly because it's a really difficult problem. You've got these, the blades are 120 meters long. Some of them, the biggest ones, in the North Sea on a tower that's like 150, 200 meters tall. And you've got a guy hanging on a rope off it. So it's a really difficult problem to start with. But we applied for funding, and we were lucky to work with a guy at actually don't remember the name of the organisation, but it's a renewable energies organisation based in Scotland, and they were sort of helping with some of the testing and stuff, verification behind it. And he really helped us with the application. The main thing he kind of said was just answer all of the questions on the
answer them extremely clearly.
So I think we'd had a list of all of the questions you had to answer, and we'd bullet pointed all of the questions, written out a paragraph for each one, then removed all of the bullet points and just put it into a big block of text. And he just went back through and put all of the bullet points back in. So there's just no question.
Because he was like, it really easy.
He was like, the first thing they'll do is they'll go through the list of questions and then go, did this application answer every single question? If it didn't, it gets thrown in the bin instantly, basically. So it's like, if you just answer all the questions, you're already into like the final few, and your chances have just gone up like a few 1000%.
We'll have to definitely take that for our next one.
I would say the other one is having partners as well.
Yeah.
I think they like, a university research team.
Or
just, different
or a client sponsorship, I think.
Client sponsorship. Partnership with our established R&D bodies, universities, or kind of research institutes, or whatever it is, for sure.
So with coming back to with the stuff we were talking about earlier, with you guys having a keen interest in trying to improve process, but felt like you had the shackles attached in your previous roles. How does that kind of, what did you see in your previous roles that were holding you back? Some examples of that. And I guess as a small studio now, what kind of things are you doing, working with software, blending that with the kind of construction, and how are you trying to solve those problems now?
I don't know if it was as necessarily a feeling at the time that I kind of felt shackled. I think it was more, I've always had a lot of ideas for different things, and I kind of just wanted that kind of sort of freedom to start working on them. Or I did start working on one of them, so then I was kind of working on something else as well as my kind of day job, and then that kind of snowballed into two things, and then suddenly there was not time to do those things and the day job. So then that kind of took over. It was more maybe of a snowball rather than like a kind of a single crystallizing moment.
One thing I see all the time, well, I felt it and I see it all the time in engineering firms, is they don't have the time or space to try a new thing. So you have, a deadline next Friday and you have to deliver a certain type of work. And they'll say it, people understand and they realize this, they don't have time to try the more efficient method in case it doesn't work. So the space to take a risk and try something new and fail, I think definitely that's frowned upon in an engineering firm.
There were definitely a few moments though that did make me think this is slightly insane. Like there was an architecture company I worked for, my first job after my master's, and the project I was working on, we just had a big submission, and the client was we were waiting for client review. So I had nothing to do. Like the day after, I was just sort of in the office. There was literally nothing on my project that we could do. And I asked one of the other people, can I help out on another project? Is there anything I can do? And they said, no, because we don't want if you come and do a day on our project, we have to basically resource you to our project for a day, and we don't want that on our budget. So, I basically just had to sit there and do nothing for a whole day because the company was paying me anyway.
I think it's very rigid systems.
Yeah, there's very rigid systems. I was like, surely someone can see that this doesn't actually make sense.
But I think that also feeds into an idea we spoke about recently, which is the efficiency of smaller teams, and so in a way smaller companies, which then collaborate with other companies to make these larger teams for projects. I think when you are a small company, you have to have more simple systems in place to make it work, and also less rigid systems. Again, I totally understand. You're in a large company like Ramble or Foster's, where I worked, thousands of employees. You do need some sort of system. But I think, letting people fail a little bit, try something and reward someone trying something.
So it's
rather than playing it safe all the time.
It's not like a lack of want or ideas within those firms. It's just their kind of money talks basically, and they got to get
deadlines
the projects.
Talk, right? And I understand, and it's they'll say they completely know, but we don't have time to do it. We don't have time to figure out a better method here, which is sort of where I think we can sort of come in, because we do see ourselves, or often we're collaborating with larger firms. So I think if we can be the sort of experimental arm of a larger company, even temporarily, I think that's a role that we can really help
definitely with. And I mean, I think we've spoken about it, like construction is complex. There is a lot of different parties involved, and obviously the risk is also high if something goes wrong, and therefore that's probably why maybe some processes are stuck to it, because they work and they've been successful to get there.
But I think the early stage design risks are not as high as people think. So maybe it's not a good to see this as a positive, but many design stages overrun by a week or a month. So to push your first deadlines and issue something that isn't quite right for the sake of a day or two.
Yeah,
I don't think that's necessarily the best idea.
Yeah.
That's definitely where we end up working quite a lot, and where we definitely think there is room for sort of the industry generally to move kind of in that direction, is that kind of very early stage consultancy or kind of early stage rationalization or optimization, getting into getting our specialities in terms of geometry, fabrication, all those sort of things in much earlier in the project, sort of ideally very early in the design process with the architects.
And that's something
before things have gone so far down the line that you're kind of stuck.
Yeah, people are locking stuff in
you're
way
stuck
too
with something
early.
that has to be done.
Yeah.
And there actually isn't a very efficient way to do it because of a whole bunch of reasons that the guys who designed it would never be aware of, because it's not their
And
it's not
do you
their
think
speciality.
the reason why, obviously you just mentioned they're not their speciality, the why they're doing it is because they don't know better, or they don't have the right tools available to them to make those decisions? Or
they probably don't know better, but like not necessarily sort of through their own fault. It's just not their, it's just not what they kind of do on a day-to-day basis.
Yeah.
I think to a degree though that the problem is that there is this very strict kind of time division of how a project progresses.
Yeah, and I think that happens too early.
The design happens with the designers, then procurement or tender, whatever, and then it kind of moves into construction, and there's not really that much communication between those phases. Whereas if you can get, particularly people like us, who I think maybe some of it comes because you don't want to tie yourself into like working with a fabricator at the start of the design process, for example. So I think maybe that's one of the reasons that things get kind of pushed further down the line. That's maybe why it's easier for us to jump in earlier, because we're not, we haven't got a piece of the cake down the line. So we're not trying to, you're not committing to anything.
Yeah.
But I think if you can basically take some of the expertise from the downstream stuff and inject them upstream, so that then better decisions can be made that allow for more sort of efficient processes. And
surely what you guys are doing with computational design and building applications has to play a part in that, in terms of making that easier, quicker to surface the thing. So are there like particular projects you guys are working on at the moment that are of a kind of interest and highlight that?
Yeah, so I think an interesting one would be one of our collaborators called Structurecraft, who are Canadian timber builders. So they do engineering, fabrication and install. And by doing all of those things, they can make really good decisions quite early in the project, which is helping them later in the project. And we're supporting them on making some in-house software called Branch, which is all about early stage quick decisions that you can show to the client. And also that software then goes into the detailing stage. So I think software can certainly help people make good decisions more quickly. The big challenge always is whether the software is constraining you. Because, whatever piece of software you use, even something very flexible like Rhino that we really love, partly for its flexibility, the tool you use will always affect the design you make in some way, sometimes in a good way, sometimes in a bad way. And I think the challenge with the early stage quick design tools is that everyone will have quite boring rectangular buildings. There's quite a few brands or companies at the moment who are doing sort of planning software. I think there's sort of 5 or 6. And all the buildings look the same. And they're just sort of rectangular office blocks. Sometimes they have a little corner in them. Maybe that's fine, and maybe they get enough data from those, and then you'll do a more detailed design after. But I think that's the risk with the software tool, is very boring design and not much risk.
And you were speaking before about the use of timber and extending tall buildings on top. Maybe it'd be good to talk a bit more about that project. It sounds like quite an exciting one you guys are working on. Yeah,
so this is the Optopen project, where we're looking at adding timber stories onto existing timber buildings. And there's quite a few reasons why this is a good idea. Instead of knocking down a perfectly good building, you just refurbish it and add 2 or 3 stories on top.
Non-existing timber buildings.
Yeah, sorry, did I say existing timber?
Yeah.
Sorry, okay.
Just any existing building.
Absolutely. So any existing...
almost certainly not timber buildings.
Yeah, exactly. Yeah. So usually not a timber building, and often an old building. And one thing I like is that this is a way of retaining the character of a city. So instead of you knock down all these lovely buildings from 100 or 200 years ago, you maintain those amazing facades and those amazing buildings, and you just add additional things on top.
Or also buildings that were built quite recently, so say 60s, 70s, concrete kind of office blocks or something, which maybe weren't built all that well, but the fundamental concrete structure of it is really sound. So you might, rather than demolishing the whole thing and building something that's more sort of modern in terms of its standards, actually just refit the existing structure and add a bunch of lightweight timber on top.
So presumably the project that you're going through has to kind of go through the same design phases that any other project would go through.
Yes. Well, so our project is actually, so it's called optoppen, which is Dutch for topping up. If you get a very small beer and you just say optoppen, you get your beer filled up. But what the project is it's not a specific building. It's basically marketing for the idea of optoppen. So we are trying to spread the idea that this is a good thing that you could do with your existing buildings. And the target audience is building owners and policymakers rather than necessarily architects or engineers.
Yeah.
So absolutely, once you use the tool, you'll get a rough idea of how many stories you could add, the carbon rating for the new structure. But then the idea is that, the policymakers are convinced you'll go into a more traditional design phase, but having learned about this idea of optoppen.
And how are you using technology then in relation to that project to make, how would you kind of guarantee that you can get the design right easily, quickly, and probably guarantee a bit more of program and cost certainty with that then?
Yeah, well, so the way you calculate how many stories you can add, or this is how many you can add without significantly changing the foundations, you calculate the weight of your current building, you take a certain percentage of that, and that's how much you can estimate that you can add. So you add your timber stories, you figure out how heavy they are, and then you keep doing that iteratively until you have a number. Another option is how many stories you remove from the existing. So it's quite common to remove the top story of the existing building, and that might give you 2 or 3 extra timber buildings. So yeah, you have that process, and then I've actually forgotten the question.
So you would aim to use some computational design there to be able to do that quickly.
I'll finish off that idea. So basically the way people usually calculate that is with a spreadsheet or with a lot of tables. So you'd usually go to an engineering company and they would do a chunk of work for you and figure out roughly how many stories you could add very early on in the project. So this is bringing that stage of engineering, quite simple, straightforward engineering, but bringing it right to the beginning of the project. And what we've done is we've made a web app, and I think there's a few reasons why a web app is interesting. The main one being is if you're marketing an idea to someone, I think you have to be really quick. You can't say, hey, developer, go and download this software, install it on your computer back home, figure out how to use it, and then you have a result. What we're doing is we're sending you a URL. You can open it on your phone, your iPad, or your computer at work, and instantly, within 3 seconds, you've got what would have been a chunk of engineering time. So yeah, it's the very early stages of engineering, but it's still a bit that you would have had to engage an engineering company to do. And it's really exciting. We're hoping that this will sort of spread. The idea is that you can quickly get a result for your building that you own, but then share that building with your colleagues or other people, and kind of share the idea, which is quite new for us. We're usually designing things, a building or a product, but here we're actually playing the role of marketing, basically.
Yeah, and is the question, obviously, for you guys, you'll know from your previous practices, is there a threat to those firms because they basically charge on a kind of time and materials thing, that if they can use all these things which are making their lives a lot quicker, that there's kind of a bit of resistance internally to use that, or is that not something you see?
Well, I actually think that is, true. I think, for one engineering company in particular, what's the benefit if they just make their process much quicker, right? And as you say, they're charging less. And I actually put this question to a professor when I was studying about this thing. I said, have we won anything? We've done all this much more quickly. Have we won anything? And he said 2 things. The first one was, well, if you don't do it more quickly, a rival engineering company will do it more quickly. So you have to just get quicker and accept that you might make less money on that one. the other thing which is specific to Optoppen is that we're working with Whitby Wood, an engineering firm, and they are specialists in Optoppen. So the more people who have this idea and want to push this, the better. And also this early stage stuff we're replacing is probably, a week's work probably for the engineering firm, as opposed to, the year or two that they might spend on the project. So, and then the final point, which is why us and Whitby Wood and also the organisation who are funding it, Built by Nature, are interested in, is there's really, really good environmental reasons to do this. So you're not creating all this building waste, which is a huge problem. I don't have the number, but it's some crazy percentage of the waste in the UK is just construction material. And you are making more dense cities. And a more dense city, I always think is counterintuitive, is actually a better, or is in a more environmentally efficient city. So Jack always says something to me that, we imagine the people living in the countryside, surrounded by green fields, living a very sort of environmentally positive lifestyle, which is kind of where my parents live, and I think where your mum is living.
Yeah.
But for every delivery they get, there's many more miles of carbon. They drive everywhere they go. So actually, it's not a very efficient.
And then maintaining, wide road networks, services, all the rest of it. Bigger houses, completely detached, no shared walls with other houses. So
So actually, creating these dense cities is another good reason for the Optoppen idea,
and by extension, dense countries as well.
It seems strange.
The UK is a very dense country compared to the US, which is just so much more efficient. There's large sections of the US where they're kind of converting a lot of more rural roads into just dirt track again, because it's just too expensive to maintain. And this road that goes 30 miles to 4 houses or something.
So we all know that. So it sounds like we're based in London. London obviously has lots of densely population. I think it's something crazy does it swell to 12 or 13 million people in a day? There's a big need obviously to keep building high rise and things like that. So how is maybe some of the stuff that you're working on, or some of the things that you can spot that either through Optoppen or other kind of technological methods that we think might help, or what can the construction industry brace to kind of deliver that?
Yeah, I don't know actually. I mean, it's not something that we spend a huge amount of time thinking about.
I think one of them I think is what you guys are involved in a lot, which is precast. So we first connected through our friend Mark Paniski, who works a lot in ultra high performance concrete. Reinforced concrete with fibers, and I think what he's done is that concrete has a bit of a bad name or a bad rep in terms of sustainability, but I think there are quite a few people doing really interesting ways to minimize the amount of concrete in the structure. So he's which I think you guys are working quite closely with them, have created really, really thin concrete panels, reducing maybe more than 50% of the concrete you need. And that's, those are the numbers that are quite interesting. I always found if someone told us about a new practice that saves 10% or 5%, it's just sort of, it's not really enough. You want bigger numbers, right, than those. So that's one of them. There's also...
I guess generally just building speed. And that kind of comes back to the whole kind of prefabricated sort of elements. Whether it's concrete or timber, but offsite, getting stuff up quickly and in higher quality.
And surely using some of the computational design or software stuff so that better decisions can just be made throughout the project, right?
Yeah, definitely. I mean, we kind of do this a lot. Obviously, the work, almost all of the work we're doing is in that direction, mostly in timber.
I think one of the things that you get from, not just computational design, but just doing digital modeling of your project, I think having a really accurate model of what you're going to build benefits the whole process. And I think that's something that has taken off pretty significantly. The level of detail that people are modeling before they build the thing.
Yeah, and sort of thinking. We're saying that one of the kind of the interesting similarities between designing products, or sort of products, let's say, which are intended for mass production, is So the general process there is you're front-ending all of your complexity. There's a huge amount of time and process and everything goes into getting everything set up perfectly. So that when you go, okay, let's hit production now, it goes bang, everything starts rolling, and you're throwing out hundreds of thousands of whatever it is, a month or a week or a day if you're Apple probably. So all of that complexity and getting everything kind of perfected in terms of processes goes on before you start really actually chucking the product out. Whereas conventional building kind of feels like it's almost the opposite. There's always like a big rush to get on site, get everything started, and it's more of a philosophy of like, we'll figure it out as we go kind of a thing. Which then means you're trying to problem solve at the same time as doing the actual thing, which then inevitably leads to like big delays and holdups and things, while certain things, it's like we can't fix this problem in a day. It's going to take us a month to fix it. And then you've got like a bunch of guys who can't do anything, or a whole section of the building that gets held back. Whereas we tend to be working on sort of timber stuff, which is much more kind of computationally led. And that's almost a bit more like building huge products, really. It's like all of that, often you're dealing with glue lams or big timber elements that are all CNC'd, like a big kind of jigsaw puzzle to just perfectly sort of slot together on site. So that's a bit more like all of that thinking and preparation and process has to be done before you cut a single piece of timber. Because if those timbers arrive on site and nothing goes together, then you're completely screwed. So it's a bit more of that kind of product thinking.
And how do you think we can get that into general projects then? Because it is the number of times that you reinvent the wheel on a project is just crazy. Yeah. And you always have like construction sites where people are screaming for stuff, or things don't fitting, things aren't going together, and that obviously you have those problems you just mentioned. So like with some of the stuff that you guys are doing, whether they're small, or is there any bits that we can learn from other industries so that we can front end that? Clearly some of the modern methods of construction, like you mentioned, precast and stuff, it requires that, but is there any other thing you think from your experience?
So the one thing we come back to a lot is prototyping. So making and testing the thing either at a scale or at the scale that you're going to build. And I think the other one is that we're trying to keep on track of is knowing when you can create a bespoke thing, or knowing when you have a product, because the sort of scale in which you can make a bespoke product and work on a building is quite it changes all the time, and it depends on how you're going to build that element. So I think that's pretty useful for Jack's, or having Jack's sort of day-to-day experience in the product design industry, seeing how many, do I need to order 1,000 of these or 100 of these for them to be cost effective? Mm-hmm. I think the other thing that's really important is making sure we make really good buildings. So if you make a crappy building that gets knocked down in 20 years, that's pretty much the worst thing you can do. So making sure the buildings are good quality, so they're not leaking, for example, but also that they're loved. This is kind of stolen from Thomas Heatherwick. One of the books which I recommend is his Humanized book. Slightly controversial, I think, with some people, but the message is that if people love a building, that building will survive. We'll reuse it, we'll adapt it. And I think that's, again, going back to maintaining the character of our cities, I think that's really important. The other thing I think about a fair bit is there was an IKEA, I think it was IKEA, built maybe 5 or 10 years ago, and when it was launched, it was the most eco IKEA ever.
Oh yeah, I think it's...
Is this in Tottenham?
Was it Tottenham?
And it was an incredible building, incredibly efficient, and I think they knocked down an existing building, which they sort of ignored in the calculations. And then it's now, I think it's already been knocked down.
Yeah, I think it maybe got knocked down and a supermarket got built there instead, which was then showcased as the most
that's right. Then the new thing was the new most environmental. And it's just, I'm sure they were, and the designs probably were good ideas. But if it gets knocked down in 5 years' time, then it's a complete waste. You might have saved 50%, but that's still 50% that you've wasted. So yeah, buildings that are good enough is in practically good enough. So they're watertight and they're warm and they're not too hot in summer and not too cold in winter. And buildings that are loved, I think those are just the key things. And you can justify other interesting materials. I think, a concrete building that lasts 200 years is a much better idea than a timber building that lasts 20 years, for example.
Yeah, definitely.
So I think that message, I think, is quite rightly come to the fore.
Yeah, and I think obviously with the development in technology and basically being able to analyze these different options quickly, easily up front, so that you can probably make those decisions.
Yeah, and compare different materials.
Yeah.
Yeah.
Cool. So to finish off, we're going to introduce some quick fire round questions. So can you tell me one thing you're excited about for the construction industry for 2025?
Have you got your answers?
You can make it up.
I'm not sure if I was briefed on the questions.
So, okay, well, so this is one which is not necessarily new, but this is the sort of, there's various people looking at the same problem, but the various plywood and OSB timber structural box systems. So you might have heard of WikiHouse or Block Build or U-Build. And this is where you CNC a sort of flat pack furniture of your building, and then you sort of assemble boxes, so timber structural boxes, you fill it with insulation, and then you take it to site and you create this really airtight, hopefully everything fits together perfectly system. And it really appeals to me, partly because it's something that I think I could do, as in we could do the modeling ourselves, but also be on site and just sort of actually put this thing together. I think there's two reasons why I like that. One is so I know exactly what's in the building. I've had kind of bad builder experiences in the past, so I kind of just want to know that it's really good quality. And just the experience of building and making a thing is a lovely experience. One of the reasons why I think we do what we do.
Yeah.
So to know that I sort of built my extension myself, as long as it doesn't go badly, would be really exciting. So maybe that's 2025 is my plan.
Well, let's come back in 2026 and you can
where you have a podcast studio in your newly extended house.
Yeah. Well, it's interesting. The architect is a little bit skeptical. The other client, my wife, is a little bit skeptical. But I genuinely think we can do a cheaper but really, really beautiful thing.
Yeah.
So that's my... Yeah. But I've been talking about this for a number of years. So
every year we have a kind of a sort of a start of the year thing. It's like, what will we absolutely do this year? And I think every single year since we started, we've said we'll build a little prefab timber structure of some form.
Yeah.
And every single year we say it, and every single year we don't.
I think next year's the year.
2025.
Yeah.
The year for building prefab.
Yeah.
Well, and you could model it in Grasshopper.
Well, definitely. And the other thing that we've been playing around a little bit is the idea of this prefab timber structure combined with Optopen. So Optopen is generally heavier glulam CLT structures, but we're always sort of looking for a sneaky little gap in a situation, like where can we sort of find an opportunity? And we have been sort of badgering people who own buildings to just let us build our new studio on top of their building. So yeah, if anyone has an empty roof,
there's maybe like a sort of an interesting smaller level. Optopen is normally kind of treated as like a relatively big thing. It's like you've got a big office block or a big industrial building or whatever it is, and you put a big several stories of CLT on top. I think one thing we kind of find interesting is if you've got a small building, even just like a terrace house or whatever it is whether there's a way to then kind of do a like miniature scale Optopen with tiny little units that you can carry up staircases, or like that kind of much smaller scale kind of densification. Yeah,
I don't see why not. I mean, the number of houses in London you see which are being having extensions or things like that done, all done so very traditional. Like pretty much all of them are traditional.
Yeah, and I think planning is the main restriction at the moment. I mean, we a couple of years ago we wanted to try and convert our loft in our house, but to do it with a warm roof construction meant we would have had to raise the ridge line of the roof by 200 mil or something, and not even making a step. We were just going to continue the plane of the front side of the roof. So it would be almost impossible to tell, and the roof is between two chimney stacks, so there's no continuous roof line. It would be, you'd have to stand a long way away and really try to tell that it had been moved. And the planners rejected it because they said it would change the character of the street too much. So basically we actually didn't go ahead with it but it basically would have forced us to do a cold roof construction, So there's this like, I feel like with the planning process at the moment, there's this very annoying conflict between the government saying we need to insulate our buildings, we need to, make the whole building stock much more environmentally efficient. And at the same time, they're saying you can't make micro changes because of ridiculous like concerns about sort of loss of character and things. Which is, I'm not saying that the loss of character in the whole is a ridiculous thing to be worried about. Obviously, that is important, but it's so minuscule, the things at the moment that you are not allowed to do to try and improve sustainability.
Yeah. Well, they're supposed to be making some changes, aren't they, at the end of this month? Well, I guess we'll see what happens.
Yeah, fingers crossed.
Yeah.
I think it's really, really
maybe you
needed.
get your warm
We'll get our warm roof. We'll get our warm roof.
I've also just remembered one other construction thing it's sort of this year, but hopefully we're going to see a lot more of it next year. So there's a company called Minimass who is a friend of mine from Foster and Partners days, and they have been looking at making a much more efficient concrete beam. So rather than having a whole rectangular block of concrete, they have the sort of top bit of concrete, which is in compression, and then they have a sort of external tension cable. And they're again, interesting numbers of like 50% less or like 70% less concrete, but making these really strong and like long spanning concrete beams. They recently, I think in the last couple of weeks, did their first full scale prototype. And yeah, maybe next year we'll see a few more of these. And they look really interesting as well.
Yeah, really nice.
So yeah,
very
shout
cool.
out to Andy at Minimass.
Very, very cool. You were telling me about how you kind of don't want to fall back on the standard way of doing things and you want to follow best practice. Do you mind telling me a bit more about that?
So I think sometimes we kind of feel like the best practices, which most industries rely heavily on and are very effective, they're not really the best practice. They are the safest practice in that it's the way that lots and lots of people have done the same thing for a long period of time. And you know that you will get the thing you want eventually, but it might just take a really long time or have a lot of hiccups on the way. And often we're kind of more interested in trying to find the actual best practice, which is literally the most efficient, highest quality way to achieve a certain outcome. And that kind of is what I think the industry kind of often relies on. Like best practice over time slowly moves forward and gets better and better and better. And that's because people kind of reach out ahead a little bit, experiment. Some things might fail, some things might work. When something works, if enough people then kind of gather around that new way of doing something, that creates the sort of the momentum shift that can move the whole industry forwards a little bit. So I think that's kind of where we like to try and find ourselves, is in that kind of pocket where we're trying out new ideas, trying new methods and ways of doing things to try and improve.
Yeah, and I mean, in all industries, there must be such an opportunity in construction to do that, because I can't remember what the stat was, but I think in terms of productivity gains compared to other industries, it lags far and away behind. And so with what you guys are trying to do, I think trying to disrupt that and show that there's a different way is really exciting. And in terms of 2025 and what you think you're most excited to see in construction, is there anything in particular?
So I'm kind of excited to see a bit more of some of the things that we've been working on actually the last year or so, which is these sort of miniature customized software elements. So we mentioned with Optopen, which essentially is like a little sort of miniature program for quickly analyzing this sort of building extensions. But we've been working on a few other kind of platforms as well with a few different companies. We've been working with a company who design lightning protection systems for buildings, and a couple of others we can't really talk about at this point. But taking this company's been doing lightning for decades, and using a very, very similar process, manual AutoCAD sections, hand calculating this sort of rolling ball type algorithms. And they kind of came to us wanting a more efficient sort of way of doing it. And we've developed this web app, which basically allows a fully automated sort of process. They can bring an IFC model into the web environment. They can just click anywhere on the building. It drops a lightning protection pole. You can adjust the angles. You can cycle through their sort of inventory to replace it with different types of products. The whole time it is simultaneously running in real time a rolling ball algorithm calculating the mesh of protection that's provided. And it's going to be sort of orders of magnitude sort of saving in terms of efficiency for them.
Yeah, I think when you were saying, one thing that's really interesting there is the construction industry often uses sort of a piece of software that can do a lot of things. So Revit, for example, or Rhino, right? It's designed to be able to model a very wide range of things, but these bespoke sort of really targeted apps that just do one thing but really, really well, I think will make a massive difference.
Yeah. So I think it's becoming more, the awareness of it is becoming kind of wider. Also, they're relatively simple things to develop. And that program that we've done for the Lightning stuff, for example, was essentially sort of a 1.5 man team for like a year. And it was kind of the first time we'd really done something like that. So if we doing it again, it would be an even faster process. It's not a big scary.
That first time.
It's not a big. I think the idea of creating custom software just sounds scary because
in construction,
you would assume it must be incredibly expensive, incredibly slow, like a huge investment in something that might not necessarily do what you want in the end. But it's really not. It's quick, it's efficient, and certainly for these these kind of things that you do a lot repetitively. It's like we do this one thing over and over and over and over again. Then that's like the perfect opportunity for something like this that can step in and just make that so efficient that it's becomes like a marginal part of your time.
Yeah, 100%. I mean, if you look at other industries, the number of SaaS applications that exist for pretty much everything that you want to do over and over again, but yet you look at construction and you got these big tools like you said, Revit or Tekla, that do a lot, but in terms of the number of people that are interacting with that and all of the processes that they're going through and mini applications to help them, they don't really exist. Everyone kind of does someone manually. There's probably a number of reasons why that is. Construction historically probably hasn't had the investment or people have the money to be able to build these things, but I think some of the stuff that you guys are doing, of the advancement in AI, probably making things development quicker, cheaper.
Or I think often they get tagged on to other bits of software. So someone might try and make a plugin that plugs on to Revit or Tekla or whatever it is to extend its capability a little bit. But then you've kind of got this already huge bloated piece of software that then becomes even more huge and bloated. And it's not doing that thing optimally because you're having to build off the back of this unoptimized kind of basis for it.
And so if someone is listening and they've got a problem, I guess, can you talk to why they should reach out to you guys?
I mean, one of the difficult things with solving problems is finding problems. It's very easy to find problems in the areas that you're really well acquainted with, but you can only be so well acquainted with so many areas. So the turbine tool that we were working on, that kind of came to us because a guy who is very experienced in the wind energy sort of world, he'd seen this problem, he'd experienced it himself, and so we kind of collaborated on developing this tool. But finding the problems is the difficult bit. I think
don't necessarily come with a solution. I think for what we are good at and experienced in is, well, one thing I always try and explain, and I've never come up with a great way, but I'll give it another go, is that we're quite experienced in doing things for the first time. So, for example, learning how to do a web app, or figuring out how to make a watch or a microphone. And you could always argue, well, maybe I should just go to a watch designer or a microphone designer. And that would be a perfectly valid thing. But I think one of our earliest talks we ever did was about naivety. And I think there's a real power in naivety or a fresh look at an industry. So I think what we can do, which is interesting, is take a fresh look, do as much learning as we can, probably partner with an expert in the field. But hopefully, I think there's an opportunity there to find things which people aren't in the industry are not noticing or not spotting.
Yeah, I think there's definitely a problem where when you're kind of saturated in something, you've lived and breathed a certain industry for decades. It becomes almost impossible to look sideways at kind of novel approaches to things.
Yeah, you'll slowly evolve maybe rather than fundamentally change.
And I certainly think that's in construction, because typically people who go into construction haven't come from like a software background. it's not usually the segue that you would go into.
Yeah.
And I think therefore you end up having a lot of people who do a great job and know how to build, have they having built, but potentially don't know about some of the other techniques that could be done on. And it's also I think something that resonated with me, so for you guys, is if you're doing something over and over again and you think there must be a better way of doing things, that probably is a good time to reach out to you guys.
Yeah, definitely. I think also sometimes it can just be kind of, we sort of mentioned before, but just the structure in big companies isn't necessarily set up to solve kind of interesting small problems. It's however the resourcing is set up or whatever it is. If there isn't like a dedicated department for doing that one thing, sometimes it becomes really difficult to do that one thing. Because it just doesn't fit in anywhere in the sort of the way that your hours are billed or whatever restriction it is. So we've definitely found that over the years. Sometimes the companies that you would assume would be the most innovative and they've got almost infinite resources and almost infinite manpower. Like, how would they not solve this themselves? Sometimes it is literally just as simple as there is no mechanism for someone to step away and go, hey, I'm actually just going to go and try and solve this little problem for 2 weeks. It's just sort of it's not feasible within the way the company works.
The thing I always come back to is a lot of optimization algorithms. So if you're trying to optimize any problem, a whole chunk of them involve randomness. So you're trying to optimize, you're looking around in this little space for a solution. And a lot of them will then inject some randomness. So all the parameters will suddenly change and you'll try and look at a completely different solution. So I kind of see that as like, that's one of our little roles, is we're the sort of like randomness injection into the industry that can hopefully find new options. It won't always work, and sometimes those new things will be a failure. But yeah, as a sort of, like if we're trying to optimize something, let's inject new ideas and changes.
Yeah, it's sort of like the global optimum versus the local optimum problem. Like if you're on top of a mountain and you can't see anything because of the clouds, how do you know if you're on the highest mountain or not? And it's kind of a problem that recurs a lot, is you think you found the best way of doing something, but actually
because all around you,
if you just walk down and back up again, you'd find there was actually a much bigger mountain just next to you.
Yeah. So I think if we can be that nudge for the industry to kind of try things.
This is like was it Ivor that did this?
Maybe. I don't know where you're going.
Someone's child I know found instead of crawling, they just slid on their back.
New way of getting around.
Yeah,
but it was so fast that they never bothered learning to crawl, and then walked really late because it was like they could slide on their back like twice as fast as other toddlers could walk. Like, why would I bother learning to walk when I can slide on my back this fast?
Different ideas, fresh thinking.
Yeah, exactly.
Yeah. Cool. Well, thanks guys for joining me today. Really appreciate it. First episode.
Yeah, thanks for having us.
It was great to talk to you
really
guys.
Great. Thanks a lot.
Cheers.